Continental Drift Theory. Continental drift theory is a scientific hypothesis proposed by Alfred Wegener in 1912, which suggests that the continents were once joined together in a single landmass, called Pangea, and have since drifted apart to their current positions. The theory was a precursor to the modern understanding of plate tectonics, which explains the movement of the Earth's lithosphere. Here's a breakdown of the key aspects of the continental drift theory. Origins of the theory. Alfred Wegener, a German meteorologist and geophysicist, proposed the idea that the continents were once part of a supercontinent. He suggested that over millions of years, the continents had moved apart to form the current configuration of the Earth's landmasses. Evidence supporting continental drift. Wegener gathered several lines of evidence to support his theory, which included fossil evidence. Similar fossils of plants and animals were found on continents that are now widely separated by oceans. For example, fossils of the extinct reptile Mesosaurus were found in both South America and Africa, suggesting these continents were once connected. Fossils of the plant Glossopteris were found across southern continents like South America, Africa, Antarctica, and India, indicating they were once part of a larger landmass. Geological evidence. Similar rock formations and geological structures were found on continents that are now far apart. For example, the Appalachian Mountains in North America closely resemble the Caledonian Mountains in Scotland and Scandinavia, suggesting that the continents were once connected and experienced similar geological processes. Paleoclimatic evidence. Evidence of past climates, such as glacial deposits, showed that regions now located near the equator once had polar climates. For instance, glacial deposits found in South America, Africa, India, and Australia suggest that these continents were once situated closer to the South Pole. Evidence of coal beds found in Antarctica indicates it was once located in a much warmer region, as coal forms in tropical conditions. Fit of the continents. The coastlines of continents like South America and Africa seem to fit together like pieces of a jigsaw puzzle. While not perfect, the apparent matching of continental edges suggests they were once part of a larger landmass that later broke apart. The supercontinent Pangea. Wegener proposed that all the continents were once connected in a supercontinent called Pangea, which existed during the late Paleozoic and early Mesozoic eras, about 300 million years ago. Over time, Pangea began to break apart, and the landmasses slowly drifted to their current positions. Pangea was surrounded by a vast ocean called Pangea. The initial breakup of Pangea began around 200 million years ago, splitting into smaller continents that gradually drifted apart. Rejection of continental drift. Although Wegener's theory was groundbreaking, it was not widely accepted during his time, primarily because he could not explain the mechanism that caused the continents to move. Many scientists rejected the idea, as they believed that the continents were too large and heavy to drift across the Earth's surface. Additionally, Wegener's proposed forces, such as the continents plowing through the oceanic crust, were not considered plausible. Plate tectonics, the modern understanding. In the 1960s after Wegener's death, the theory of continental drift was largely revived and expanded with the development of plate tectonics. This modern theory provides a comprehensive explanation for the movement of the Earth's continents, and it is widely accepted today. Key concepts of plate tectonics include lithosphere, the outer shell of the Earth, which is divided into rigid plates that float on the semi-fluid asthenosphere below. Plate boundaries. The plates interact at three main types of boundaries. Divergent boundaries. Plates move apart, creating new crust, example mid-ocean ridges. Convergent boundaries. Plates move toward each other, leading to subduction or mountain building, example the Himalayas. Transform boundaries. Plates slide past each other, example the San Andreas Fault. The movement of these tectonic plates is driven by forces like mantle convection, heat-driven movement in the Earth's mantle, ridge push, and slab pull. Key contributions of continental drift theory. Pangea and the breakup. Wegener's idea of a supercontinent, Pangea, has been validated by the discovery of the process of continental drift and plate tectonics. Fossil and geological correlations. The fossil and geological evidence that Wegener collected is consistent with our current understanding of continental drift. Seafloor spreading. The discovery of seafloor spreading at mid-ocean ridges in the 1960s provided crucial evidence that the ocean floor was spreading apart, supporting the theory that continents drifted over time. Legacy of continental drift. While Wegener's continental drift theory was controversial in his time, it laid the foundation for the modern theory of plate tectonics, which explains not only the movement of continents but also the occurrence of earthquakes, volcanic activity, mountain building, and the formation of ocean basins. Today, the theory of plate tectonics is considered one of the most important concepts in earth science. Conclusion. The continental drift theory revolutionized our understanding of Earth's geological history. Although it was initially rejected due to the lack of a convincing mechanism, it paved the way for the development of plate tectonics, which now provides a comprehensive explanation for the movement of continents, the formation of ocean basins, and many geological phenomena observed on Earth today. Wegener's ideas are now an essential part of the foundation of modern geology.